Welcome students. We will see Unit 4 Tqm techniques. So very first topic in this is benchmarking. So what benchmarking means? Improving ourselves by learning from others. In another way, benchmarking is the process of improving performance by continuously identifying, then understanding, adapting outstanding of best practices from outside the organization. So it is nothing but comparing one's business process and performance metrics to industry best or best practice from other industries. So why are others better? How are others better? What can we learn? How can we catch up? How can we become the best in our industry? So like this, the question arises while doing benchmarking. So it is practice of being humble enough to admit that someone else is better at something and wise enough to try and learn how to match and even surpass them at it. So here we can find three main features. Continuous method of measuring and comparing, discover performance gaps, incorporate leading firms process. So benchmark is an organization recognized for its exemplary operational performance. So here are some example. Toyota is best example for process. Intel can be benchmarked for design. Motorola for training. Then Scandinavian Airlines for service. Honda for rapid product development. So what to benchmark? We can benchmark either infrastructure or human resource management or technology development, procurement like inbound logistics operations, outbound logistics, marketing and sales service. So any kind of primary or secondary activities we can benchmark. So here benchmarking process carries like this. First, we have to plan and then analyze, integrate, action, and maturity. So, in planning, the planning phase again involves three steps. That is, what can be benchmarked, then to whom or what shall we compare, then determining data collection method and collected data, either primary or secondary. Second phase is analysis. So here also we can follow two steps under phase 2 analysis, that is determine the current performance gap and the project future performance level. Then the third phase is integration. So again here we can follow two steps under integration, that is communicate benchmark findings and gain acceptance. Then establish functional goals. And the fourth phase is action. So here we can develop action plans, implement these specific actions or the progress, then recalibration, that is recalibrate benchmark, that updating may required. The last phase is maturity. So here the leadership position is attained. So this is continuous and breakthrough improvement. So there is a continuous improvement, then suddenly a breakdown happens where highly competitive situation are faced by the organization. Then some innovation and changes we need to accelerate. So this is called, here we have to benchmark these things, and here we can make a breakthrough improvement, and again it will be a continuous improvement. So what can be the advantage of benchmarking? Product and process will be improved, time and cost will be reduced, competitive strategy can be made out. Here we have disadvantage like what is best for someone may not suit us. Poorly defined benchmark may lead to wasted effort and meaningless result, incorrect comparison, reluctant to share information. So here we have types of benchmarking. That is product, performance, then process and strategy. So what is product benchmarking? So under project benchmarking, this refers to comparison of different features and attributes of competitor product and services. So it is done through either engineering analysis or through analysis of perception of customers. The next one is performance benchmarking. This refers to comparison of performance indicator related to a business as a whole or the group of critical activities or process. So it compares different kinds of system performance also. Next one is process benchmarking. This refers to comparison of process. So it identifies a more effective and efficient process to be implemented. Then strategic benchmarking. This refers to examining competitive position in the marketplace. So it helps the company to study the business strategy or another successful business and use the strategy for becoming more competitive. Apart from that, we have another type of classification also, which is based on the organization. Previous the classification was based on object. So this is based on organization. Here we can see internal, external, then generic, then international, best in class, best of the best. So what is internal and external benchmarking? It refers to comparison of different performance between department and subsidiaries within the same organization is internal benchmarking. External refers to producing same class of product and service. Then generic refer to general best practices which are common across industry sector market. Then international means comparing our industry with the abroad or foreign industry. Then best in class, it refers to comparison of performance with best practice prevalent in the organization, irrespective of product or service. And the next topic is failure mode and effect analysis. So it's really critical. So what is FMEA? It is based on knowledge. It is a risk assessment. It controls quality. It also helps in continuous improvement. So what is FMEA? Classification of failure by severity of the effect, how often they occur. So for failure mode and effect analysis, also known as risk analysis, is a preventive measure to systematically display the causes, effect, and possible actions regarding observed failures. So the objective of FMEA is to anticipate failure and prevent them from occurring. So here originally this FMEA was developed in 1940 for US Navy and utilized in the Apollo space program to minimize failures of expensive prototypes. So what are the benefits of FMEA? Reduce cost, then prevent failure, reduce scrap, prioritize the risk, then engineering and manufacturing knowledge base. We can see two types of FMEA, that is design and process. And other FMEA types of concept, system, service, equipment, maintenance, then environmental. So the main is design and process. Design FMEA involve the analysis of the potential failure of product or service due to component or subsystem unreliability. Then it is also established priority based on expected failure and severity of those failures. Process FMEA involve a failure analysis of the manufacturing process. The process FMEA is used primarily to identify areas of critical of control and to emphasize the design and more reliable process. So this is FMEA form where we have to come across many procedures. Before that, we should understand what are the input necessary for FMEA preparing this FMEA form. One is people input and another one is data input. So this people and data input is required for preparation of FMEA form. And what are the stages? We have four stages, that is specifying possibilities, quantifying risk, correcting high risk causes, re-evaluation of risk. And here you can see FMEA form. Here we have some basic steps for implementation of this FMEA form. So first one is identify the individual functions of component or system or process. Then second is identify individual potential failure mode. That is, a failure mode is defined as the manner in which a component, subsystem, system, process could potentially fail to meet the design purpose. Example: corrosion, torque, fatigue, deformation, cracking, electrical short, hydrogen embrittlement, etc. Then third one is identify what happened if this failure occurs. So we have to list them all. So for each failure mode, identify the engineer should determine what the ultimate effect will be. For example, it include a failure effect include injury, accident, then impaired operation, poor appearance, odor, noise, degraded performance, etc. And the next one is we have to establish a numerical ranking for the severity of the effect. So it is an assessment of the seriousness of the failure effect. A common industry standard scale uses 1 to represent no effect and 10 indicate very serious effect. And the next one is class column. So here it identifies critical characteristics. Classify any special product characteristics for component, subsystem, system that may require additional process control. The next one, we have to identify potential causes, mechanism of failure. So failure cause is defined as a design weakness that may result in a failure. So potential cause for each failure mode should be identified and documented in this stage. And the next one is occurrence. So occurrence means enter the probability factor. Occurrence is the chance that one of the specific cause mechanism will occur. So here also the common industry standard scale uses 1 to represent mortality and then to integrate inevitable. And the next one is identify what controls are currently in place. Means identify current control, that is design or process. So these are the mechanisms that prevent the cause of the failure mode from occurring or which detect the failure before it reaches the customer. So the control may be supported through tests, mathematical studies, feasibility reviews, and prototype testing. And the next one is determining the likelihood of detection. That is D. It is an assessment of the likelihood that current control will detect the cause of the failure mode or the failure mode itself. So likelihood of detection is also based on 1 to 10 scale. 1 is certain of detection, 10 is uncertainty of detection. Next, we have to calculate risk priority number, which is equal to severity into occurrence into detection. So RPM is used to prioritize items that require additional quality planning or actions. And the next one is recommended action. What can be done to reduce the severity, occurrence, and detection rating? So this is the outline for continuous improvement. So determine recommended action to address potential failures that have high RPM. Next one is we have to assign responsibility and target completion date for these actions. Then indicate what are the actions have taken. Reassess the severity, occurrence, and detection, and review the revised RPM. So finally, you see whether the RPM is getting decreased or not. If not, you have to clearly check this FMEA from the first procedure. So likewise, we have to update FMEA. Here we have some examples for FMEA. And the next topic is quality function deployment. It is an approach to design introduced in Japan in 1966 by O.G. Akko. So here also Toyota strongly influenced the adoption of QFD in North America. So what is why we need QFD? A lack of well-defined product development process in research and design can be the root cause for the ruination of the company. To have a successful product, we must understand user needs. So what is QFD? It is a very systematic and organized approach of taking customer needs and demands into consideration. So quality function deployment is the latest approach to product design. The true meaning for phase QFD is customer driven product. This is otherwise known as voice of the customer. So what are the main objectives? To identify the true voice of the customer, to help the organization and analyze the information associated with the project. So in this we can see 4 phases, that is product planning, part deployment, process planning by production planning. So in the phase 1, product planning. So what is product planning? So under this we have to list out the customer requirement and what are the technical description available with us. So design requirement and customer voice or needs is done in the phase 1, that is product planning. Then in part deployment, that is second phase, we need to concentrate on design requirement and parts requirement. So here deploy QFD process down to subcomponent level in both in terms of requirement and characteristics. Then third phase is process planning. So here we have to develop relationship between critical characteristics and process used to create the characteristics. So develop the control plan relating to critical control and to critical process. And the last phase is the tablet operating instruction from process requirement. So develop, prototype and do testing, launch the final product to the market. So this diagram is house of quality. So what is house of quality? The primary planning tool used in QFD is house of quality. The house of quality convert the voice of customer into product design. So it is used uses a series of matrix diagram, so-called quality tables. So here we can see the basic structure of house of quality, where the first is customer requirement. So this exterior wall of the house are the customer requirement. Then section 2 is prioritized customer requirement. So the right hand side, prioritized customer requirement matrix are listed. Then section 3 is technical description. That is second floor or the ceiling of the house containing technical descriptors. So here the product design characteristics are expressed in engineering terms. And section 4 is relationship matrix. This is interior wall of the house. It is a relationship between customer requirement and technical description. And the section 5 is trade-off matrix, the roof of the house, in the interrelationship between technical description. And the foundation of the house, that is the section 6, is prioritized technical description. So some of the items included are technical benchmarking, degree of technical difficulty, and target value. So this is the diagram we draw in QFD. So here the symbols are given. Then a matrix is also shown between technical description and customer requirement. Then calculation part, which shows prioritize of customer requirement and prioritize of customer technical description. What are the QFD benefits? So it creates forces on customer requirement, uses competitive information effectively, then prioritize resources, promote a better understanding of customer demand, then identify items that can be acted upon, structure resident experience and information. So it improves customer satisfaction, promotes teamwork also, then facilitate better understanding of design interaction, then concentrate on design effort, then minimize the number of later engineering changes. So overall, it reduces the overall cost of design and manufactures. Next is total productive maintenance, which is originated in Japan in 1971 as a method for improved machine availability through better utilization of maintenance and production resources. TPM is a maintenance process developed for improving productivity by making process more reliable and less wasteful. TPM is an extension of total quality management. The strategy of TPM is to change the attitude from I use you maintain to I use I maintain. So what are the goals of TPM? Increase production, create job satisfaction, then employee morale, increase in employee morale. So why we need this TPM means avoid wastage in a quickly changing economic environment, producing goods without reducing product quality, reduce cost, produce a low batch quantity at the earliest possible time. Then objective of TPM are to improve equipment effectiveness, to announce autonomous maintenance, to train all staff in relevant maintenance skills. To plan maintenance, to achieve yearly equipment management is also another objective of TPM. So here we can see the pillars of TPM. So here we have 8 pillars of TPM. The first one is autonomous maintenance, means pays a responsibility for routine maintenance such as cleaning, lubricating, inspecting in the hands of operators. And the second one is planned maintenance. Sorry, focused improvement. So have small group of employees work together proactively to achieve regular incremental improvements. And the third one is planned maintenance. Here, what is it? Scheduled maintenance tasks based on predicted and or measured failure rates. And the next one is quality maintenance, means design error detection and prevention process. So here we apply root cause analysis to eliminate recurring source of quality defects. And the next pillar is education and training. So we have to train the knowledge gap necessary to achieve TPM goals. And the next one is development management. So here, yearly equipment management is necessary. The next one is safety, health, environment. So maintain a safe and healthy working environment. Then TPM administration or office TPM. So here we have to apply this TPM techniques in administrative functions also. So here we have stages like the preparation stage, preliminary implementation stage, TPM implementation stage, then stabilization stage. So what is preparation stage? We have to announce the top management to introduce TPM and also launch education and campaign to introduce TPM. Then promote team, then establishing TPM policy and goals, then preparation of formulas of the master plan. All this is carried out in preparation stage. Then preliminary implementation stage, where we have to invite client, affiliator, and subcontracting companies to hold a TPM. The next one is TPM implementation stage. In this, we have to develop an equipment management program, then develop a planned maintenance program, then develop a autonomous maintenance program, then increase skills of production and maintenance personnel. Then step 11 is develop yearly equipment management program, means design, commission and control the maintenance prevention program. And the last stage is stabilization stage, where we have perfect TPM implementation and raise TPM levels. So here we can see in this picture implementation of Tqm. So this is purely a teamwork, not individual. So big loss. What are the 6 big losses? We can find breakdown is also one kind of losses. Then setup and adjustment, small stop, reduced speed, startup reject, production rejects. So thank you students. We finish TPM with this.